Hello students, welcome to lesson number 9 on circle theorem. The last time we met we looked at lesson number 8 and we were on theorem 7, where we saw that anytime a radius meets a tangent, the angle formed between them is 90 degrees. Anytime a radius meets a tangent, the angle formed between them is 90 degrees. In other words, the radius of a circle is perpendicular to the tangent of a circle. Good. Now, in our lesson today, we'll finish up with all the theorems. So it's left with last 2 theorems. So we'll deal with that and then we'll move on straight to solving examinable questions. So when we are done with the last 2 theorems, the rest of the lessons will be solving of variety of examinable questions. So we'll be solving variety of examinable questions. Good. So let's move on to our lesson for today. Good. So we are now on theorem 8. Now, the diagram I have here is a circle with what? 2 tangents. So CB is a tangent and then CA is a tangent. Okay, so we realize that we have how many tangents? 2 tangents. We have 2 tangents. Good. And you can also observe that they are all from the same point. That is point C. So a start line or tangent CB starts from C. Okay, so from C through to B and to this point. Tangent AC also start from C through A to this point. Okay, good. Now the theorem is saying that anytime you have 2 tangents, okay, from a common point to a circle, okay, anytime you have 2 tangents from a common point to a circle, the theorem is that the 2 tangents are equal in length at the point of contact. The 2 tangents are equal in length at the point of contact, meaning line CB and then line CA are equal. That is why this dashes are there. So this one and this one is telling us that line CB and line CA are equal. So you have to take note, it is at the point of contact. It is at the point of contact to the circle, not beyond. Okay, so they are equal at the point of contact to the circle. I hope you get it. Good. So anytime you have 2 tangents to a circle and from the same point, the 2 tangents are equal at the point of contact. The 2 tangents are equal at the point of contact. So line CB is the same as line what? AC. Okay, so for instance, if I draw a chord through the point of contact, okay, so from A and then let's say B, if I draw a line through, let me see, yeah, okay, so let's see the line. Okay, so with this line we have a triangle, that is triangle A, okay, triangle A, B, C. Okay, now what it means is that line AC, okay, is the same as what? Line BC. So they are equal in length. So it is only at the point of contact that they are equal in length. So we can say that triangle ABC is an isosceles triangle. is an isosceles triangle. I hope you get it. Good. So that is Theorem 8. Now let's move on to Theorem 9. Good. Now with Theorem 9, it's most of the time not in some of the textbooks, but it's also a relevant theorem. We have to add it. Okay, that's why I'm adding it, because I told you in our first lesson that we are going to look at about 8 theorems, but this one too, it's very important, so we just have to look at it. Good. Now you realize that I have a circle here, and then I have a chord AB. Okay, so there is a chord AB, and then there is a circle, and this is the center of the circle. Now this Theorem 9 says that if I draw a line, okay, if I draw a line from the center of the circle, if I draw a line from the center of the circle to the chord, okay, if I draw a line from the center to the chord, the theorem says that this line that I draw from the center of the circle to that chord bisects the chord. So this line from the center of the circle to the chord bisects the chord, and it's also perpendicular to the chord. So meaning that any line drawn from the center of a circle to a chord, it's a perpendicular bisector of the chord. So a perpendicular line is basically a line that makes what, an angle of 90 degrees with the other. So this line is a perpendicular line, but once it is dividing the chord into two, we say it is a perpendicular bisector. So it can be from this side to this side, okay, here. So even though it will be a straight line from here to here, it will be a perpendicular line, but not what, a perpendicular what, bisector, because it's not what, bisecting it. Okay, so if I draw a line here, okay, this line is perpendicular to the chord AB. Okay, it's perpendicular to the chord AB, but it doesn't what, bisect it. But this line from the center of the circle to this chord, okay, it's a perpendicular line, alright, but it bisects what, the chord. So the theorem says that any line drawn from the center of a circle to a chord is a perpendicular bisector of the chord, meaning that that line bisects what, the chord. So it means this side, if this is, let's say, C, it means that AC is the same as CB. Okay, AC is equal to what, CB. So AC is equal to CB. That is what the theorem says. So it means that if I extend the line, okay, to get to this end, and then I also extend it, it means that that line is what, a diameter. So in other words, the diameter of a circle is a perpendicular bisector of a chord. Okay, so the diameter of a circle bisects a chord equally. I hope you get it. Good. So any line drawn from the center of a circle to a chord bisects the chord, and it's what, perpendicular to the chord. I hope you get it. Good. So this line here, it's a perpendicular bisector of the chord AB. So the angle here is 90, the angle here is 90, and then the length here is the same as the length here. Okay, I hope you are okay with it. Good. So students, these are all the theorems we have to consider under circle theorems. Okay, so now that we are through with the theorems, our main aim is to make sure we familiarize ourselves with all of them. We should be able to identify them when we see them, and then we should be able to apply what the theorem says on questions. Okay, good. Now, mainly, the WASSCE circle theorem questions is virtually, from what I've observed, are in 4 categories. One category is that they will just ask you questions on the theorem. So that one is, there's no big deal with that. The second category is that they will mix up the theorem in a question for you to apply a variety of theorems on a single question. The third one is that they will give you a diagram, and then they will ask you to prove that either when you add one angle to one and another angle, it will give you 90 degrees. Or when you add one angle to another angle, it will give you 180 degrees. Or you should prove that a quadrilateral is either a square, a parallelogram, a rhombus, whatever. Okay, so the third one is more or less like a proof. So you have to know this. First is just basically testing you on the theorems. Second is testing you on the combination of the theorems. And then third is letting you prove some relationship in the diagram that you see. And then finally, they will describe the diagram in words for you to draw it yourself, and then you solve questions under it. So the last one is that they will, instead of they drawing the diagram for you, they will not draw. They will write it, they will describe it, and then ask you to draw, and after that they will ask you to find some angles in the diagram that you've drawn. So for you to confidently know that you have dealt with circle theorem, you should solve variety of these 4 areas of questions. Okay, good. So we'll end our lesson here. What I will tell you is that now relax, go over the theorems one after the other. Make sure you are able to identify them whenever you see them. And then the next time we meet will be solving of questions. So I'll make sure we treat all the 4 categories of questions. Okay, good. So I will leave you with a question, so an assignment. So do this assignment for me. It's a beautiful question. Apply all the theorems that you know to the question and then solve it for me. So let's see the assignment. Good. So this is the assignment. It's not difficult. Read the question. Don't get scared by the diagram. Read the question, know what to apply on it, and then you make a headway with the solutions. Till we meet again, revise, read ahead. Bye-bye.